In this lesson, I'm going to attempt to give you an answer to a question I get asked really often. And that is, what is calculus and why should I learn it? Now, at the risk of confusing you, I'm going to start off with the abstract definition that most people give, and we're going to unpack it together. So the definition says that we have some input number x, and it's related in some way through a function to some output number y. Calculus is really interested in telling us how changes to the input x affect the output y. Now, because this definition is so general, it really just ends up going over most people's heads, including mine when I first saw it. But now that I've seen some of the amazing things you can do with calculus, I think it's actually a pretty good definition. So let's go ahead and unpack it with an example. Let's imagine for a moment that you had access to the value of houses in a particular suburb. You have the average house price for every single day for the last 2 years. Now, let's imagine you were considering buying a house in this suburb, and you wanted to roughly know what the house prices would look like next year. Let's pretend that we wanted to guess the value next year with nothing but the information that we're given. So over here the house price would have dropped, and over here the house price would have gone up. Using nothing but this information, you'd probably think that this value is the most likely, and these values out here are actually a little bit less likely. And this actually makes a little bit of sense. And that means if you had access to the values for the future, you'd imagine a curve like this would be reasonably unlikely, but a curve like this would be somewhat likely. I'd also be reasonably surprised if the value just jumped up here and did something like this as well. So using only this given data, we can build up a little bit of a model that shows us all the possible values of the house prices in the future. Now, what I've shown here actually colors the areas that I think are more likely with a darker color, and the areas that I think are less likely with a slightly lighter color. And as you can see, the further we get from today's date, the less sure we become about what the future looks like. If, however, we're trying to predict the value for a day that's not so far in the future, we can be a little bit more sure that the range of values is a little bit narrower. So let me just go ahead and draw one possible way that the house prices could have changed over the next year. Now, as you can see, being able to say something useful about what the future might look like is actually a very valuable skill, and it's actually one of the main things that calculus is actually concerned with. So let's go ahead and show you how this is actually related to this random definition over here. In this particular case, the input is actually time. And again, in this case, the output value is actually the value of the house. Now, the reason we always label the input x and the output y is because calculus is so general that we can apply it to so many problems. Now, as you can see, whenever the input is time, no matter what the output represents, calculus is always going to be concerned with predicting the future or past value of the output whenever we change time. So in a sense, it's the study of predicting the past or the future. Now, I'd like to give you a visual that'll make this a little bit clearer. We want to investigate how changes in time affect changes in the output value. Now, the Greek letter delta is usually used to mean change in. So we're saying that calculus investigates the relationship between changes to the input x and the output y. If it happens that time is the input, then really we're interested in predicting either the past or the future from the current value. Now, as we said, x doesn't have to be time, and that means it can be used to do so much more than just predict the future, as you'll see while you study it. Now, on top of all of this, I can tell you that calculus works really well when the function you're dealing with is smooth. Now, I should probably define what I mean when I say the word smooth. So mathematically, a smooth function is just a function that doesn't have any sudden changes in position. And it can also struggle when there are sudden changes in the slope. So as you can see, this function over here just suddenly decides to jump up to a new value, and calculus is going to struggle a bit, at least when you're starting. And similarly, this value over here looks like it's going down, but then suddenly it decides to jump back up, and this is also a bit of a problem for calculus when you're starting out. However, as we learn a bit more calculus, we can actually learn to deal with functions that have this kind of behavior as well. But when we're starting, we're going to try to avoid them. Now, we've purposefully made this definition really general. With the input as x and the output as y, we can actually adapt this to so many different kinds of functions. So let me go ahead and show you a few things that we can use calculus for on a new page. So in a sense, calculus is the study of change. Now, to talk about our first use case, let me start by bringing a car onto the screen. Now imagine that the driver of this car was being really careless, and they somehow managed to miss the presence of the wall on the other side of the screen. Now there are some people whose job it is to actually investigate a crash like this whenever it happens. And calculus would be an indispensable tool for most of them when they try to reconstruct how the crash happened. So for example, they might want to know how fast the car was going, so they might look at cues like the length of the skid mark. And they'd use the skid length to actually figure out how fast the car must have been going before the crash. So in this case, they'd investigate how changing the crash speed would change the length of the skid. Now this is just one possible relationship that they could use, but of course they could use so many other things like the shape of the car or anything else. Another incredibly useful application of calculus is predicting the weather. Now here I've got some pictures of some made up continents over here, and I'd like to ask how the weather around these continents would change as time goes on. In order to do this, I'm going to want to be able to visualize how the air around these continents moves with respect to time. So I start by actually highlighting a few pockets of air, and then I'm going to watch as they move across the sky. Now to be entirely honest with you, this is not something that a beginner would easily be able to do using calculus. But predicting how the air around a continent will move is exactly how most of our weather predictions work today. But in a simple sense, we can say that any changes to the air pressure can lead to changes in the humidity above a certain continent. But unfortunately, just like anything in life, all the more interesting examples always end up a little bit more complicated, so you end up learning about them a little bit later. However, even introductory calculus courses actually have some pretty cool applications as well. So one of the other things we actually study in calculus are shapes. Now for example, I have a picture of a vase over here, and one of the things you'd want to know about a vase is how much water it can hold. Now for example, we'll investigate how changing different parameters about this vase, like the radius of its opening, affects the volume of water that the vase can hold. So in the case of this vase, you want to relate changes in the radius to changes in the volume. Now of course, it's also possible to relate the change in volume to other parameters like the radius over here, or the height of the vase, but I've just shown you one, just for brevity. And now I'll give you one final example. Let me go ahead and draw on a building as well. Now, anytime you build a house, I think you're aware that you have to bolt it to the floor so that it doesn't move around. Now imagine we actually measured the position of the house, and we wanted to actually see how it would change with respect to time. Now a civil engineer is actually a person who gets paid to make sure that the position of your house doesn't actually change with respect to time. And you'd hope that the position of your house doesn't change even if something crazy happens, like an earthquake. Now as you can see, in all of these examples, we've seen how a change in some variable affects another variable. And this is the primary thing that calculus is actually concerned with. So as you can see, calculus is the study of change. So anytime you change one variable and you want to know how it affected some other variable, calculus is probably the tool that you're going to want to use. And now I hope that after watching this, you have a little bit of an idea of what calculus is and why you'd want to learn it. These days, I use calculus so often that I can't even imagine how I was solving problems before I learnt about it. And I hope you feel the same once you learn about it as well.